last one here. So there could potentially be one like this, where it asks you to write the expression as a definite interval. Okay? These are not easy, and I don't want to spend like a ton of time going over it. I want to go over some tricks that can help you decide what the answer would be. So if you've got a summation from 1 to n of f double prime of 1 plus 5k over n times 5 over n. Okay? The thing to remember about this is that n equals your number of rectangles. And I have messed this up right here. That really should not be an x. That should be an n right there. So what you're doing is you're doing like a limit as the number of rectangles approaches infinity, because you want the number of rectangles to go to infinity. It is asking you to write this as a definite interval. When it asks you to write as a definite interval is an integral that has limits right here. Okay, so some different things that you want to think about here. First of all, whatever the function is going to be what you're integrating. So in this case, it's f double prime of some stuff, right? So you're going to be integrating f double prime of x dx. That's what you want right here. A lot of times this shows up on free response. That right there gets you a point. Okay. Then you have to get your limits right. So this part right here, you will almost always have some number divided by the number of rectangles. This is the width of each rectangle. And what it tells you, in this case, that top number tells you that the interval has a length of 5. Okay, because if you have a length of 5 and you're dividing it by the number of rectangles, right? And that'll give you the width of each rectangle. So you're going to look for somewhere where you got like a number divided by n. It is always going to be there. It's also going to be on the outside of the function. Technically, it could be like out here. It doesn't have to be at the end. It could be anywhere. So that does not tell you what your limits are. But if you had no clue, you could do 0 to 5. And you would at least have the length right. You might not have, it really should be 1 to 6 or 2 to 7. But it needs to be numbers that are 5 apart there. To know what number it starts at and what number it's going to end at, if you're doing the summation right here, then that at the beginning you would be plugging in 1, right? And then you plug in 2, 3, 4, 5, 6, and so on. But we really want to know the beginning and the end. So if I plug in 1, I'd have 1 plus 5 times 1 over n. And notice that we're doing the limit as n approaches infinity. What am I going to get if I do that there? I will get 1, because all of this stuff right here, where it's got a n in the denominator, that n's going to get bigger and bigger and bigger and bigger, and that's just going to go to 0 right there. So we'll just get 1. That's your starting number. You're starting at 1. Because you have an interval length of 5, you could go ahead and plug in 6 right here. Here's your answer for that. Or you can plug in your final value, which you're going to have 1 plus 5n over n. and the ends are going to cancel right there, and that's just going to give you 6 for that as well. So if you take like your inside part of your function and you plug in the starting value, which should be 1 every time, and plug in the ending value, which should be n every time, that'll help you find these limits right here. The biggest thing really is knowing that when it talks about definite interval, that's the form it's looking for. It's looking for that integral. It's usually a really simple equation, like just f prime or f of something. It's usually not super complicated right there, and then finding what those end limits are.
So we just write f double prime of x dx, or we write what the equation is?
Just this, yeah. Yeah, don't try to plug this stuff in here because that's your like summation notation, which is not what you're wanting. So all of this stuff right here, on this inside part right here, it is really just like your x when you write it as a definite interval. Yeah.
If we're like on a f or q, do we have to write all of it?
You don't have to write anything but the answer. Yeah. On one like that. So don't stress out about that. It's probably going to be there. It's probably going to look a lot like this one right here, where you're going from a summation to an integral, but there will not be multiple problems asking you to do that. Probably only going to see it once for that. All right, let's see. Let's work through these first. I think these will be kind of key, and then we're going to look at the progress check problems. Okay, the table gives selected values of a continuous function f prime. The function is decreasing on the closed interval from 0 to 2. Which of the following could be the exact value of the integral from 0 to 2 of f prime of x dx? Now, nothing about that is going to allow us to find the exact value. Only thing we can really do from a table is approximate. What do you guys think we should try? It will, but do we know anything about f of x? So, like, it is true, this would be f of x evaluated from 0 to 2. So it would be f of 2 minus f of 0, and there definitely could be some problems where that's what I want you to do. But does it help you on this one? It does not, because we don't know what f is. If that table right there was f, then we could just pull off the values and it would work. But it does not help us here. We could do a Riemann sum. So if we do a Riemann sum, should we do left? Should we do a right? What should we do? If we do both, because they told us that this is decreasing, so I don't really know what it looks like, but I know it's decreasing. If I do a right-hand Riemann sum, where the right corners touch the graph, a right would be an underestimate. And if I do a left-hand Riemann sum, where it's the left corner that touches, then that's going to be an overestimate. So if I do a left and I do a right, then I will be able to hopefully narrow it down to where there's only one number in between those. So remind me what to do. If I want, let's do the left first. So integral from 0 to 2 of f prime of x dx would be approximately Okay, so that'll be 0.5. And for a left Riemann sum, what would I multiply that by? Okay, so since these are all the same length interval, right? I don't have to do them separately. I could if I wanted to, but I could just, like, all of these are 0.5. So I could just pull that 0.5 out front. And so it'd be f of 0, which is 10, and then 8, and then 7, and then 5. I use all the points on the left. I do not use 4 for that one. I'm sorry, we're integrating f prime, so I should not be calling it f. It's f prime for that. And so then, let's see, that's going to be 20, 30, half of 30. I think you get 15 there. So left is overestimate is not 15. That's too much. And then for the right Riemann sum, I'm betting that it's going to be 12, because if it's 8, we've got a problem, right? But still, my width of each rectangle is 0.5. And then I would have 8 plus 7 plus 5 plus 4, because for that one, I am going to use the 4. I do not use the 10. And that is going to give me half of 24, so I get 12, so it's not that one. That's my underestimate, so it's got to be B in the middle there. Like, I think the problem I'm thinking of that's similar to this is even a calculator active question. You know, they could give you, it could really go either way. It doesn't help you all that much that it's calculator active. Another option on that is your trapezoidal sum is usually really close. So if you do a trapezoidal sum, it might give you something really close. Okay, let's look at this next one. Okay, this one is calculator active. It says, for what value of x does all of this stuff have a relative minimum on the interval from 0 to 3? Right. Okay, so let's forget about integrals. Let's think about what we knew about derivatives. If I wanted to find a minimum, what did I do long ago? We're wanting to know where does the derivative switch from negative to positive? There, right? That would give me a relative minimum. So I haven't tried it with Desmos. I don't think we can graph that integral because of the x right there. You might be able to. Let's see if it will. Equals. Let's see if it works. This may be a new 1, 2, x of ln of cosine of t to the second plus 7e to the negative t, and then we would need like an extra set of parentheses here, dt. Let's graph something. Let's see if that's the answer. Maybe. But let me do the other way that I know that will work as well, and we'll see. It might graph it. Actually, I think let's see, do you have to put the y equals in front of it? You do have to put like a y equals or f of x equals or something in front of it there, I think. Let's see if that gives us the right answer. What I would think about before being able to use Desmos on this exam, because the TI definitely won't graph that correctly, and if it did, it would be so hard to see, it wouldn't be helpful. What you're doing is you're taking the derivative of that integral expression. And whenever you take the integral of a derivative, what happens? It just basically cancels out. So that derivative is just going to be this inside stuff right here. I bet I need to use an x instead of a t. There. So we are just looking on the interval from 0 to 3, so let me restrict this 0 less than x less than 3. Right there. And let's see. Actually, I have two answers that I probably did not include. I probably should have cut that off a little sooner. I'm thinking this does not quite work because it gives you like a weird answer there. But if I look at that blue graph right there, yeah, I don't think that works because it gives us a different value. Oh wait, it was asking. Yeah, I don't believe that works right there for that. We'll look at progress check problems that are like that too to make sure I've not messed something up. But if we take the derivative here, we just have this function, and we're looking for where this switches from negative to positive. So negative to positive is just this one point right here, and it's going to be at 2.28591. So x equals 2.28591. This is probably going to be multiple choice, but if it were for response, you would say because your derivative switches from negative to positive. There. Sure. All right, questions? All right, let's look at 3. Way too much. We've got the integral, the derivative of the integral from 5 to 3x squared of the square root of t plus 3. This was not anything you guys had a terrible time doing. It's just been a long time since we did it. What do we have to do when we take the derivative of an integral like this? Okay. That stuff right there gets plugged in for t. That's really what we did up here also. It's just, it was just an x, right? So it didn't really look much different there. So we're going to get the square root of 3x squared plus 3. Is that it? It's not it. You do not have to do that on these. It's like a chain rule. You have to multiply this by the derivative of whatever you were plugging in. So we're multiplying this by the derivative of the 3x squared, which would be 6x. So they will probably write it this way: 6x square root of 3x squared plus 3. Try another one of those to make sure we can do it. Let's do this. The derivative of the integral from negative 2 to the square root of x of x plus 3 over x squared. Or let's see, hold on. I needed to use a dummy variable right there. That would never be an x in both places. They'd put a t squared dt. Yeah, new problem. This is just another example to make sure that we can do this. I'm throwing it in.
That was the answer for 3.
Yeah, this is the answer for 3. Yeah.
That's all we need.
Yep. So try this next one to make sure we can do that, because it's not like when we did it, you guys were good at it, but I think we've forgotten it. All right, what's the first thing I'm going to do? That square root of x gets plugged in for the t's, right? So that will be the square root of x plus 3 over the square root of x squared, which some of you went ahead and said that's just x and didn't write that part down. That's fine. But then I got to multiply by what? The derivative of the square root of x. So you may even want to think over to the side. That is x to the 1/2. So that's going to be 1/2 x to the negative 1/2. Okay, so you plug that value in, and then if this is anything besides an x, you got to multiply by the derivative of that. They'll probably clean this up a little bit. That's square root of x plus 3 over just x times, they'll probably make this 1 over 2 square root of x, like that. So they'll probably say square root of x plus 3 over, they might do 2x square root of x, they might do 2x to the 3/2 there. But this would be your answer here. So if you're taking derivative of an integral, just plug in that top limit. The bottom one should be a number. It doesn't matter what that number is as long as it's a number. And then multiply by the derivative of that top, or that top limit right there. Okay, let's look at 4 real quick, and then we're going to skip over to the progress check. This is the type of problem they give you a lot of times with U substitution. They may not ask you to solve it all the way, because if you solve it all the way, it takes a really long time to do. So they tell you what the U is, and they ask you to write an equivalent expression. Which one do you guys think is correct? Okay, B. You have to change all the variables, because if this right here like doesn't, like if they had put like an x equals here and x equals, then it would be okay, but they did not, so it's not B, because your u would be x squared plus 3, that's this right here, and du is going to be 2x dx. So you got the x, you need a 2. You got to put a 1/2 out front. So it's not A or D because you need that 1/2 out front. And so you've got 1/2 integral of the square root of u du. But unless they put x's, and they did not, the limits have to change too. So you got to do u is going to be 0 squared plus 3, which will give you the 3 that goes here on the bottom. And over here, u is going to be 2 squared plus 3, which is going to give you the 7 that goes on top. So C would be the correct answer there. There's very high probability chance that you will see a question like that. So make sure you're really careful and choose the one where the limits change, because there will always be an answer choice that's right, except for they didn't change their limits. Okay, questions? Let's look at some of the ones we were missing on the progress check. Let's see. I'm not going to spend any more time on Riemann sum integral sort of stuff. You're not going to see a ton of that. One. You only see one. Or no, I'm sorry, not, I said that wrong. The summation, like the E. Riemann sum, you may see several of those. Riemann sum would be like where you have a table. Yeah. Yeah, sigma notation with the sum and the E, that. Only one. Yeah. It'll be very similar to the one that we did there. So that's not a big one. Okay, this one right here we did not do very well on. But we essentially just did this. Okay? So, they give us h. They're asking us to take the derivative of h. But h is an integral defined function. So what are we doing when we take the derivative here? We're doing a derivative of an integral. Right? So for this problem, I'm going to have to make this where I can write over here. For this problem, you are taking the derivative of the integral from -1 to x cubed of the square root of 2 plus t squared dt. So what do we need to do? X cubed gets plugged in here. That's going to give us square root of 2 plus x cubed squared. What else has to happen? Multiply by the derivative, so that'll be 3x squared. So we'll get 3x squared square root of 2 plus x to the 6th there, which is D, which is our answer for that. So that one is like, it's not that difficult if you remember what to do. I think probably most of us that missed it didn't know what to do with it there. Okay, let's see another one that we missed. I don't want to do summation ones. Here's another, like we're missing that one pretty badly. Didn't mean to expose you here. But if I'm taking the derivative of an integral, what's the only thing I have to do? Plug the top in, multiply by the derivative of the top. In this particular case, you are just replacing your t with an x, and the derivative of x is just 1, so it doesn't change anything right there. So it's just a right there.
Is the d over dx mean we're taking the derivative of it?
Oh, I'm sorry, it's getting cut off.
How am I supposed to, like,
Oh, just the derivative.
That means you're taking a derivative.
and so if there's not that, then we're taking the integral.
Well, on the problem that we just looked at, it told you that h equals the integral from -1 to x cubed of all that stuff. And then it asked you for h prime of x, so that didn't have that d over dx, but it was asking you to take the derivative of something that was an integral. So that's another way they could ask it.
And that's when we plug it in and then multiply the other.
Mhm. Yeah.
So,
Mhm.
when it comes to taking the derivative, why is the number on the bottom of this chart?
The reason is because whenever you take the derivative, that second part's going to be a constant. Like if we actually integrated that, we don't know how to integrate, but if we actually integrate it, the second part would be a constant because you're plugging a number in. When you take the derivative of a constant, it's just 0, so it goes away. So as long as it is a number, it does not matter, and everything you're going to see of this nature will be a number. Okay, now don't make this think you're not going to actually integrate, because let's go down here. I think it's actually on part B more that you see. Like whenever you see, if you saw a problem that was the integral from -1 to, x, it could be x. They're probably not x, so you'll probably see a number there. To 3 of 2x plus 1 dx. This is asking you to integrate. It doesn't have that derivative out front, or ask you to take the derivative of it. So you're just integrating there. Let's look at 13. We'll keep clicking on the wrong thing. Okay, so we've got this picture, and they ask us to find the value of the integral from -1 to 3 here. When we integrate, what does that look like on the graph? How do we represent an integral? Yep. So here, whenever this asks us for the integral from -1 to 3, -1 is right here, 3 is over here. It wants the area between the x-axis and our line. So this part right here would be part of it, and this part right here would be part of it. And in this case, you can use area formulas for that. But if something is below the x-axis, what do we know about its value? It's negative. So like right here, this has an area of 3. You got 2 full blocks, and then that triangle is going to be another full block. So this part is -3. Okay? And then over here, we would have 1/2 times the base, which is 2, times the height, which is 2. That's going to give us 2. This has an area of 2. So whenever we integrate here, we would split those two sections up. We'd have -3 plus 2, and we'd get -1 for that, which is your answer there. Okay, so an integral, when you're given a graph, can also just be the area underneath that curve. Okay, questions there? All right. Let's see. Let's look at the other part and see what we see what this one is. Okay, there's several of these on the progress check. This problem gives you f of x And it tells you it is the integral from 4 to x squared of g of t dt. And then it wants to know the value of f prime of 3. So if you're finding f prime of this, you're finding the derivative of an integral, right? So f prime of x here, you would be taking that x squared and plugging it in for your t. So it would be g of x squared. And then you would multiply it by the derivative of the x squared, which is 2x. So f prime of x would be 2x times g of x squared. So if I want to know f prime of 3, I would do 2 times 3, just replace all your x's with 3's, times g of 3 squared. So we got 6 times g of 9. What is g of 9 going to be? It's going to be 4 because it's right here, which is not marked, but we know g of 8 is 5 and g of 10 is 3, so it's halfway between. And we'll get 6 times 4, which is 24. Okay, questions about that one? Okay, this one is a U to U substitution, but see here again, it does not ask you to like actually solve the problem. It's just wanting the setup of that one. What would you have to use for your, I mean, obviously the answer is chosen, but what has to be the U for this one? It's got to be sine of 4x. Why can it not be cosine? This is being raised to the 5th power right here. So if you think of it being written like this, it's like cosine of 4x times sine of 4x to the 5th power. If they had written it like that, it would be a lot easier to see that that needs to be the U. Right there. And then so your du, derivative of sine is cosine. You must multiply by the derivative of the inside, which will give you a 4. You've almost got your du there, but you need a 4 right here, which means you'll have to put a 1/4 out front. And so this stuff right here is your du. This is your u. So you've got 1/4 integral of u to the 5th du for that. Okay, anybody else have one they just remember want to see the last one? Yes. So on that test review for number 5 here, this is the graph of f prime. It is known that f of 5 is -2. But this is f prime, this is not f, so we can't just read it off of a graph. If I want to know f of 7, the way I'm going to have to do this is I'm going to have to say the integral from 5 to 7. I'm going to have to use 5 every time because that's my starting point. I know that. It's going to be f prime of x dx. And so when I integrate f prime, I get f, right? And so I will have f of 7 minus f of 5, like this. So this part right here can be found from the graph. So from 5 to 7, that's this little piece right here on your graph. And that has an area of 2. So I can replace all of this stuff right here with 2. F of 7, I do not know. That's what I'm trying to find. But F of 5 is negative 2, so I can have that there. So 2 equals F of 7 plus 2. I would subtract 2 from both sides, so 0 would be my F of 7 there. And the other ones are going to be similar. They're going to be a little harder to do for that, because you would have, like, for that negative 1, you would set up like the integral from 5 to negative 1 of f prime of x dx. That will be f of negative 1 minus f of 5. Like that. You will find this from the graph and then plug in your negative 2 over here, and whatever you get here, solve that the same way. Okay. The key for that's posted if you want to work out those other two that are there too. It should be posted for that. I do have Smart Breakfast on Monday if you have any questions.